Do you want to wait a little bit, I guess, until
Yeah, that's fine. Why
6:30?
don't you tell people about your office hours and things like that? So while we wait for the next couple minutes for people to start.
Okay.
dropping in.
Sure, yeah, that works. Yeah, so let me share my screen. Should be this one. Are you able to see that?
Yes.
Okay, great. Okay, so created a lot of notes for today's session, which you can find first and foremost if you're joining right now. So just to recap, this is obviously the series for making a video game through the I've Squared Center at the New Haven Free Public Library. I'm your host, so to speak. My name is Page Swanson. I am a professional software developer, I guess you could, easiest way to put it. Yeah, I've been running these sessions for a while. If you're not familiar, the hub for this series is at this URL. So github.com/Page Swanson, it's me, /library game series. And we'll be going off the notes here. I will post in the chat the link to this for people joining. Oh, nice. Oh, thanks. Great. And at this site, you can also find the link to my office hours, which we also just posted in the chat. I hold office hours every Monday from, as you can see here, 6:30 to 8:30 p.m. Actually, yeah, I may start coming in for those I guess. I mean, so if you happen to be in the library, that way maybe a little more visibility, I can put up a little sign. So in case anyone is just curious about programming.
And for those in Facebook land, those are posted in the comments. So the GitHub for this series, as well as the link to sign up for office hours.
Fantastic. Great. Yep. And then, of course, last but not least, my email through the library is coder@nhfpl.org. You can email me any questions you have or anything like that, and I'm happy to answer all kinds of stuff. Anything about programming, really, I can do my best. I've had a couple of people reach out to me about getting their career started or what that looks like. Happy to answer questions like that. So it's really nice to get questions like that. Happy to try to help out. Okay. I guess we can go ahead and get started.
Yep. I'm just going to put headphones in so that I don't bother the other people in the space.
Oh, yeah, of course.
So you might not be able to hear me because I don't think this has a microphone.
Ah, gotcha. Okay, no problem. All right, so yeah, without further ado, I'm going to open up the notes for today. So I just have all of these dated. If you want to look at previous session notes, basically, if you're just starting today, that's no problem. You should be able to go just kind of one by one through these previous sessions. You'll just go by date. So I think January 13th is the first one, and then the 27th, etc., all the way up to today, which is the 31st of March. So this is the one we're going to start with today, which is part 6. So we've been kind of moving along with our game, and at this point, our game is actually pretty. It's getting to the point where it's going to be pretty full-fledged. We're introducing a lot of stuff that makes this kind of an emergent, playable game. So this is pretty exciting point to reach if you're following along. And again, if you're just jumping in, this will be hopefully maybe the push that you need to do it independently and get caught up. So yeah, today basically we're working on moving obstacles with our player character and creating a puzzle in the game that we can navigate. So actually going back to the root of the project, if you want to follow along, there's instructions for doing that in session 2, I think it was. Yeah, programming part 2. So this shows you how to use the Godot editor, which is the game engine we're using, how to create a new project and stuff like that, and how to load a project. So if you want to follow along here, if you're just jumping in to get Godot set up, then what you can do is just download this folder called Space Game. And this will have everything you need to catch up to where we are for this session. So, okay, so I'm going to go back here and basically, yeah, get started with this part. So I'm going to go ahead and open the game in the Godot editor. So I already have this folder here. So you can see it's just called Space Game. It's just the same folder that you would download from this site. So it's no different. So I'm just going to double click on that. And I'm actually going to make sure I'm in the right place on my computer. I am, so that's good. So this is exactly where we left off with minimal difference from the last session. There shouldn't be any changes. So all the stuff we did during that session, this should be reflected here in this version of the game. So what I want to talk about first is kind of introduce this concept that we kind of need. We don't necessarily need to understand, but it's going to help us organize our interactions, our kind of game interactions when we start colliding with different objects in the level or collide with the level itself. So we have to have this sense of basically what should collide with what. You know, how do we get informed or notified that a collision happened? Like if you think of a kind of conventional game where, let's say something like maybe I don't know, like a platformer like Mario, where basically you have coins and you have things that you can step on and you have enemies and things like this. All of those collisions behave a little bit differently. So a coin, Mario needs to collide with the coin, but then the coin disappears because Mario kind of obtains the coin. And then a platform, Mario should collide with and land on top of. And an enemy, Mario should collide with, and then we should do something in the game to where the enemy disappears or they get hurt or something like that. So this is kind of the concept that I'm talking about with layers and masks. And this is just the way that Godot handles or represents the collision system. So where can we go to see kind of where this is represented? Yeah, so all of this stuff I just kind of described. To define, though, really quickly, this idea of layers and masks, I think it'll be helpful to look at one of our scenes that we've been using. So this is our main level scene called Planet Zero. And we have our player character called the Castaway. So I'm just going to go over to the right-hand side and look at this inspector section, or whatever you want to call it, inspector tab. This is showing me a couple of different sections. One of the sections is 2D collision objects properties section. So basically it's a section where I can outline or detail collision properties and this little section called input properties. But basically I have this layer property and I have a mask property. So the way that Godot handles the collision system or represents it is basically everything sits in a layer and you pick the layer that it sits in. So if I go to a Castaway right now, and let's say I open the script for the Castaway. We're going to open an editor like this. Yeah, so let me move this out of the way. If if I go to the inspector on the castaway, I've already assigned a layer and a mask to it. Well, actually, I think these are just default. So it already has one assigned. I didn't necessarily assign it. So the object here is basically that we have a layer where this scene resides. So the castaway scene resides in layer 1. And that's arbitrary. We could pick any layer for it to reside, but typically with Godot games, you have your player character reside in the first layer, just for simplicity's sake. The mask is basically dictating what layers are observed by our scene. So this is the layer we're in, and the mask says these are all the layers that we can see. So if I were to remove this, what it would mean is that any object that's in this layer, I wouldn't be able to collide with it anymore. Not by default anyway. Godot would not basically process those interactions with the physics layer or the physics engine. So it's kind of hiding interactions for us or making interactions basically non-existent. Hopefully that makes some sense, but it'll probably make a bit more sense as we start assigning these layers and masks and then using them for the collisions. We already used a layer in a collision last session, but we didn't do anything with super progressive with our assignments. We really just made sure that the castaway was in layer 1, and then our slime obstacle, which are these little items here, we went ahead and assigned them to layer 3. So if I go look at a slime obstacle, I open it in the editor, it's on layer 3. Okay, so now that we have all these different types of scenes, though, this layering system is pretty helpful because basically it can give us kind of an overview of all the different ways that different scenes are colliding and interacting with each other. And what we can do is, instead of dealing with these as just numbered layers, layer 1, layer 2, layer 3, etc., that's not very memorable, we can give them meaningful names so that when we create new scenes and new instances of scenes, we can use this layer system to kind of keep things organized. So all of this to say, basically, we're going to go make some layers. We're going to label some layers, and then we'll use them. That's pretty much what we're going to do. So the way we do that, we can go to project settings, and we can find layer names down here. We can go to 2D physics. And basically what we're going to do is assign layer names for 1, 2, 3, and 4. And the names we're going to use match or line up with the scenes that we already have, or the types of scenes. So we have a castaway, which is just our player character. We have obstacle, the obstacle layer. So I'm using the obstacle layer to represent basically anything that the player cannot, really interact with other than to collide. So like a wall, the level itself, the boundaries, boxes that can't move, anything like that, I'm going to put on layer 2. Slime, we can call slime obstacle or slime, whatever you want. That's going to be on layer 3. So this is a unique layer because anything in this layer, we want the player to be kind of killed by or reset by. And finally, we have this movable obstacle layer. So I'll just call it movable. It doesn't really particularly matter. Basically, anything in this layer, I want to be able to interact with. I want to push it. I want to be able to touch it, and I want to have interactions with other things within that layer. This is the way I'm kind of conceptualizing this. Okay, so I'm going to close this. And once we've done that, usually you have to save or something like that. Usually I go to scene and save all scenes. Sometimes Godot won't show it to me. Yeah, okay, so there it is. So now if we look in the castaway scene, if we pull that up and you hover over these layers, now they're named. So this is pretty useful because you can just kind of keep track of that much more easily when we do the layer assignments. You can do the layer assignments for a scene without naming the layers, but it's useful to name them so that you know basically for your masks what layers you want to interact with. So once the names are in place, basically we're going to go through all of our existing scenes, the ones that we have, and we'll go ahead and we'll mask them based on what we expect. Before we do that, let's go ahead and play the scene that we have. So we'll play it and we'll make sure everything works as we expect. So I'm colliding with the boundaries of the level. That's good. I collide with this obstacle. It's not meant to move. I can't move it. Collide with it, so that's good. If I hit this slime, it resets the player. That's good. So all of our collisions are working as we left them last time. And what I'm going to do is start making these layer assignments. So the first layer assignment, the castaway. So I'm going to open that in the editor. And I already have it by default set to layer 1. So the castaway is occupying layer 1. And we want this to collide with all layers. So we want to track collisions and interactions with every other type of layer, which makes sense, right? We want to be able to touch slime and see what happens. We want to be able to touch movable boxes and see what happens. We want to be able to touch obstacles and walls. And you don't have to put it with itself, like you don't have to really mask it with itself because we're not worried about collisions in this layer. But like, let's say we added an enemy, we might want to put that in layer 1 because they would work very similarly, or they would collide very similarly to the way that we do. So we would probably want ourselves to collide with that enemy. So I'm going to go ahead and put it in that layer. But it would be pretty easy to work out what you needed to do if you didn't do that. I mean, you would figure that out later. Okay, so we save that one. The next one for obstacle scenes and the tile map, we want to collide with, so the castaway and movable obstacles. We haven't made our movable obstacle yet. We're just making the layer for now, but that's okay. So I'm going to go ahead and open this obstacle in the editor. This is the base scene, so I'm editing this property, and any obstacle that we add later on will now have this property, this layer property set. So this is obstacle, and it collides with the castaway and the movable obstacle. So castaway, movable obstacle. So I'll save that. And the same thing for the tile map. Go over here to the inspector, we'll select it. So this is like the level. So this, these boundaries here and all of this, these walls. We'll just go here, put it to layer 2. And same thing, it can collide with 1 and 4. And we'll save that. Okay, finally the slime obstacle, finally for now, we haven't made the movable obstacle yet, but finally the slime obstacle, that collides with layer 1 and layer 4. So just like the normal obstacle. So the way you can think of that, right, is if I'm thinking about what layers this should interact with, what does the slime do? Well, it hurts the player. And then you think about all of these different scenarios that you'll be adding to your game. Well, eventually the player is going to be able to move boxes. Do we want the boxes to be able to go through the slime, to pass through it? Probably not. We probably want the box to push up against the slime if the player moves it that way. So that's what we'll do. So 3 and 1 and 4. So I already made that assignment. So great, we're done there. Okay, so now that we've made all of our layer assignments, so the castaway, the slime obstacle, the obstacle, and the tile map, Those look good. So now we're going to play the scene and just make sure everything still works. Okay, so we're still getting reset by the slime. That's really good. And we're still running into these walls, and we're still running into this box. So that's great. And just to really quickly show you, I should be able to actually break this. So I'm going to unmask the slime from layer 1. And I'm going to unmask the castaway from layer 3. So the castaway can't see anything in layer 3, which is the slime. And the slime shouldn't be able to see anything in layer 1, which is the castaway. So let's see what happens. It still resets. Well, okay, I'm kind of cheating a bit. Let's actually, it's because of the way we programmed the interaction. We're just checking to see what layer we're in. Let's just ignore, let's just remove it from this layer. And we'll put it in like layer 1. So now we're just colliding with it like a normal box. So we can change the behavior by moving the layer, and we can put it in layer 2 and same thing will happen. Okay. So we'll put it back in layer 3. We'll let this interact with the castaway again. And thankfully, there aren't a lot of implications right now for this layer and mask system, the way we have the game programmed. But if we were to add more complex collision interactions that depended upon these layers, it would be it's kind of a useful thing. So it's a bit apprehensive to start talking about these, but I think it's an interesting concept that Godot uses. So I think it's worth mentioning. All right. With all of the layers and mask system kind of properties discussed and out of the way, yeah, let's just remind ourselves of our objective, because that's a good thing to do anytime we continue working on our game, so that we make sure we stay in scope. We know exactly what changes we plan to make for this session, and we'll try to make them. So we have very clear objectives, and we can understand the amount of time that it will take to do them. And overall, we'll have a better sense of the progress we're making on our game. So it's just good to revisit that kind of thing. So basically, we know that the basis of our game is to avoid interacting with slime. We got to stick to what is not slime. And what we're doing today is we're implementing a moving block that would allow us to open up spaces or change the terrain around us, and to kind of manipulate the levels. So this is like a new mechanic for the player to take advantage of. So we're going to implement this movable box. So we already have a box in the game. It's this one up top. So this box, it doesn't move at all. And if we touch it, we just push up against it. So basically, we want to take this same box and we want to make it movable. This box is also super reminiscent of the slime. The slime just looks different, but it's still a box. It's just that when we touch the slime box, we disappear, we get reset. So one way to think about this is basically we're just implementing different types of this same original box. This one right here that I'm colliding with. So today we're just going to implement a new type of this same box. So of course, we're going to write code that changes the behavior of this box so that we can push it around. So the first thing we're going to do is we're going to inherit the original obstacle, just like we did for the slime. So we're going to create a new inherited scene using the top ribbon here. So I'm going to go up to the top, new inherited scene like that. And I want to inherit from the obstacle. So I'm going to click it. I'm going to click open. And basically it's opening this new scene tab for me. It's unsaved. And you can see it looks exactly like an obstacle. If we hover it, it says obstacle. It's by default, it's a named obstacle and everything. But it's new. So you can see if I hover it here, it says inherits obstacle.tscn. That's the obstacle scene file. So what we're going to do first thing is I'm going to go ahead and rename it to movable obstacle. You can also call these whatever you want. It doesn't matter. You can call them boxes, obstacles. I don't particularly care. I like obstacle because maybe one day I'll want to make them circles or different shapes or something like that. So I'm going to go ahead and save it. And it's going to prompt me to save a new file because this is a brand new scene. It's just inheriting from this obstacle scene. And by default, if you went ahead and renamed it, it'll go ahead and assign that name for you. Save it like that. Movable obstacle. And then what we're going to do is we're going to go ahead and assign it a layer. Based on kind of some of this discussion we just had around layers and masks. So note that since we inherited from the obstacle, it's got the same layer assignments as the obstacle. We don't want that. We want it to be in its own unique layer, the obstacle layer or the movable layer. And then I think we said before up here, kind of ahead of time, movable obstacle collides with all layers. So we're going to do that. Let's set it to collide with all layers in the mask. So it's in layer 4 and it sees everything in layer 1, 2, 3, and 4, which makes sense. If we're pushing a box around, it kind of should be pretty similar to the way the castaway works, the character, because we want the castaway to push this box around. So it should pretty much collide with everything the castaway would collide with. We still want it to like reset or disappear when it hits slime, and it won't do that the way that we code it. So that's positive. All right, so I'm going to get all of that saved. Do I have some water? Oh, I thought I had some water. Well, that's okay. Once we've set that, we're going to add a child instance of the movable obstacle. So this new scene that we've made to the level itself. So that it shows up in our scene when we play it. So let's go ahead and do that. I'm going to kind of click this scene node to select it at the top level. And then what I'm going to do is add a child node, or actually, sorry, specifically, I'm going to add an instance of this scene. Add a movable obstacle like that. And notice it gets put right up at the top here. So we probably don't want it there. So I'm just going to put it so it doesn't really matter where it goes for now, but maybe you could make it somewhere kind of interesting for the player to interact with. So I'm going to put it right here and save that. And it should be a sibling of all the other scenes. So all these other scenes, this is a sibling, meaning that under this tree, they're on the same sort of level. It could look different if, for example, I made it a child of the castaway, then it would look like this. So you can see that the castaway is on the same level with obstacle and slime obstacle, but movable obstacle is one layer further. It kind of looks like a file system does, like in, where you have a folder that contains a file or a folder that contains a folder, something like that. So I'm going to put it back. I just did undo. I'll put it back at this top layer under the planet. Okay, so with that out of the way, we've got our instance on the map there. And I'm going to just quickly add a script for the scene so that we can begin working on the behavior for the moving box. I'm going to go ahead and click this and click the scene node. the parent node, and then just click this button here to attach a new script. So I'm going to have it inherit a kinematic body 2D. It's going to basically be the same kind of physics body as our player character, same kind of physics body as the slime, same as the obstacle, the box. Obviously, it's the same as the box that inherits from the box. So that should make some sense. What I'm going to do is just make an empty template here. I don't need all the extra stuff that typically comes with the script. Movable obstacle.gd is a fine name, nothing wrong with that. So I'm going to create it. And basically, it's just going to, by default, it's just going to extend kinematic body 2D. So we have access to all these physics properties and functions that are on this this type of object in Godot. Okay, so I'm going to save that. Okay, so now we're going to start scripting the behavior. This is where we're going to actually, make the box movable. So currently, let's just save that, and actually we'll try to test this scene. So if we come in and test this, we can't move this box. There's nothing we did would make this box movable. All we've done is inherit a typical box or a typical obstacle which cannot move. So it should fundamentally work the same way as this. We're not worried about how it looks right now. We'll kind of implement the behavior and then we'll change how it looks. So there's nothing really differentiating these two things, except in the code, this happens to be named movable obstacle, and in the code, this happens to just be named obstacle. That's the only difference right now. So we'll go back to that. So let's open the script. We have that going in this tab right here. So our script is open for our movable obstacle. And what we want to do is add a push function, which is what's going to happen when you push this box. You can put the function wherever you want. If you would use the default template, it would come with this ready function. You could put it up above or below that, doesn't matter. So I'm just going to actually copy this right here, just paste it. And we'll just kind of run through this really quick, just as a refresher. So this is a func, meaning function, and it's called push. It takes a parameter called velocity. So that's what basically we're going to use when we want to push this box. We're going to tell it what velocity to push at. That velocity has a data type. It's a vector 2. It means it's basically a 2-value data type, usually used for like coordinates or velocities. It's just a pair of numbers. Yeah, so that's that. It returns void. So that means that it doesn't return anything. This function doesn't give us anything back. It just does something in the world. And then what does this function do? Well, if we go over to Castaway really quick, we look at that script. If you remember previous sessions, if you happen to, we use move and slide to basically move the castaway around based on our arrow keys. So basically every time I move an arrow key here, or I push an arrow key, it's going to move and slide the castaway. So we're going to basically apply the same concept to this box, except the castaway is going to move and slide it or push it. Okay, so we've added this function, like I mentioned, similar to the castaway movement. The only thing is that just because we've added this push function, it still doesn't mean that the box is going to move. We've just added the capability for it to move, but we're not using that capability yet. So we have to use that function from somewhere in order to get this to work. So we're going to do that. Okay. So we're going to open the castaway script. And we're going to review this physics process function. So this physics process is what we took advantage of in order to move around. Any interactions we want to do, any sort of interactions with the physics engine, meaning, movement, collisions, all this kind of stuff, we have to use this physics process function. So if I want to make a change in the world that involves the physics engine, I do it in this physics process function for my particular scene. So if I want to move a box, I'm going to do it in here. That's the goal. All right, so the way this function worked is basically we have a base velocity of nothing. So, you're playing the game. If I don't touch anything, I don't have any velocity, right? That makes sense. So I'm touching something, I have a velocity. I stop, I have no velocity. That's kind of the basis here. I have all these different actions that I'm pressing, and then I apply a change to the velocity in some magnitude and in some direction, X or Y. I animate my character based on these velocities, etc. The important part, though, is that I also handle collisions once I've made my movement. So when I move and slide, I'm moving and sliding the castaway. If the castaway collides with something, I want to interpret that collision and do something about it. So this is exactly what we did for a slime obstacle. And that code is right here. So we checked the particular layer that the slime obstacle is in, which was layer 3. If you go back, you can see it's layer 3 here. That's why when I changed the layer for the slime obstacle, the collision no longer behaved as we expected. If I collide with the slime, then we hide the castaway, we disable its collisions for a short amount of time, and then we emit this signal, which we deal with at the top layer, the top level, like outside of the castaway script. So now what we want to do is basically do kind of something pretty similar. We want to check for a particular collision layer on what we collided with. And then if it's a movable box, we basically want to push the box at some speed. So let's, figure that out. Right here, I have this snippet of code which represents this portion of our code. And what we're going to do is begin making a modification to it. We want to call this push function, which is on the thing we're colliding with, the movable obstacle. When we were dealing with the slime, we didn't really care about calling a function that the slime had access to, or basically we didn't want the slime to do anything. We just wanted to know whether we collided with it, and then we handle the rest. This time we want the box essentially to move. So we actually need to have a way to store the thing we collided with, not just the layer. So here we're storing the collision layer and then we're checking it. What we want to do is store what we collided with and then reference it again. So if we're reading this code correctly, basically this is all of the collisions that we had. We're going to get the collision layer, so the layer that we collided with as the castaway. And the way we do that is to basically check the particular collision, get the thing that we collided with, and then get the layer from the thing we collided with. So we're going to modify this code a little bit. I'm just going to copy this line and we'll just kind of do it manually. So I'm going to call this I'm going to make a new variable called collided with. I'm going to get rid of this int. We don't necessarily know what we're colliding with. When we move, could be any number of things. So we're not going to assume the type. This would be the type. So the collision layer is an integer, 1, 2, 3, or 4. We're not going to assume what we're colliding with. We're just going to get it. So this is how you would do that. You use this colon and then an equals. If you don't know the type, GD script, the language we're using, will let you basically infer the type. So it will make an inference on the type for you. So we're going to get the slide collision and then get the collider, and then we're going to stop there. So we'll just grab that, and we'll call this collided with. And then what we'll do on the next line is, instead of doing that same code again, we'll just replace that with this variable. So what did we collide with? Get slide collision I dot collider. So I is this particular collision of all the collisions that we had. And then the layer is just basically checking what we collided with and using this function get collision layer. All right, so that takes care of this part. So we get the collider as a separate variable and use it on the next line to get the layer right here. So now what we want to do is check the collision layer again. We checked it here on this line if collision layer equals a binary number 4. I explained this in the last notes, using binary because these layers are actually represented with binary. So you can see here, it tells you which bit is what. This is bit 0, bit 1, bit 2, and bit 3. So it starts from 0. So this would be bit 0, bit 1, bit 2, like so. So if we go to bit 2, we'll see it says slime. So this is why we're doing this. We're checking for slime. You could also say here, a bit confusingly, 2 to the 0, 1, 2, which is 4. But I don't like doing that because then it kind of reads like you're checking for layer 4, which that would not work. You're actually checking for layer 3. This is why it says value 4. So yeah, I don't know how to really clarify that language if you don't kind of understand binary too well, but that's okay. Basically, I just want to make it as clear as I can, at least. I would also be happy to explain binary in more depth if you're curious about it. But it's just a way of representing a number. It's not incredibly exotic or anything. It's just a different way of representing a number. And that's just how they chose to represent the layers. So we're going to check for a different collision layer now. We're going to check for a larger value. So instead of 3 places, it's now the 4th place, or bit 3. That's also a little confusing. So this is bit 0, 1, 2, 3. It's the 4th place bit. This represents the number 16. So you can see here, or I'm sorry, 8. So you can see here it's bit 3, value 8. That's 2 to the 3rd. If you're, trying to understand how you read this binary. So there's a 0 here. So 2 to the 0 would have basically no implication. To the 1, there's a 0 here, so no implication of that. 2 to the 2, there's a 0 here, so no implication for that. 2 to the 3, there's a 1 here, so that means we use the value for 2 to the 3rd. And you would just add up all of those evaluations in each place, and then that would give you your binary number. So really quickly, if I had a 1 here, this would be 2 to the 0. Doesn't have any implication because it's 0. We would just do 2 to the 1 and 2 to the 3. So 2 to the 1 is 2 plus 2 to the 3, which is 8. So this is 10. This is how you'd write binary 10. Yeah. All right. Yeah, so moving on. So we've checked the collision layer for movable objects now. And we got to decide what we want to do when we get to this point. So we want to push the box. How do we push the box? So to push the box, we have to reference the obstacle that we collided with. Thankfully, we stored that as a variable. This should be the movable obstacle. We could do a cast to ensure that this is the case. I actually omitted that from the code because I realized it was unnecessary. So I should remove this note. Don't worry about this. We can just reference it because we're confident that the layer is correct. If your layer is incorrect, what will happen is that you'll get an error, and I'll kind of show that error in a second. So what we're going to do, we're going to reference the little variable we created, collided with. We're going to say dot push. Now, it's not going to show up for you, so it'll be a little confusing. You'll think, maybe this isn't right. Maybe I'm not doing something right. The reason it's not going to show up, though, in your editor is because it doesn't know that this is a movable obstacle. But we are confident that it is. It's not necessarily best practice to do this, but it works well, and we're confident because of our layer scheme that this is the way we want to interact. We'll get a nice error if it doesn't work. It should be pretty clear for us. So this works well enough right now, but it's just something to keep in mind. Yeah. What we're going to do is we're going to push it at the speed that our character is moving. So you can see here, move and slide was called to move the character. We're going to do the same thing, except we're going to change the speed. The reason we want to do that, I mean, I can show you. Let's play this scene. So we'll play this. And we'll move the box. So this is great. The box moves. The problem is that this movement is pretty fast. And it's a little bit annoying, at least in my opinion, to have the player move so quickly for something where, you know, if we have like a maze game, we kind of want to be a little bit precise because it's like a puzzle. So if the box moves really quickly, I think it could get annoying for the player. I mean, this is just like a user experience kind of consideration or user experience opinion. It's totally up to you. But what I did was add some more parentheses here just to clarify the order of operations. What I did was I divided the speed by 2 when removing the box. I think this looks a lot more realistic because you're moving around quickly and then you hit the box and you slow down. So it takes longer to move the box than it would to just move around the level. I think this looks pretty nice. It looks more natural. So I went with the speed divided by 2. You could even go by 3. Play with that if you want it even slower. I think that looks pretty good as well. Yeah. Also, we can try messing with the layer identifier, and we can see the error that I was referring to. So if I try to hit this box I'm not going to get anything. And then if I hit the slime, it's going to throw a total error, invalid call. There is no function called push on the slime obstacle, which is true. There's no function called push. So it just throws an error and the game dies. So this is what will happen if you get your layer wrong. Just reset that and good to go again. Okay. So we are moving a box. So that's pretty exciting. That means our game is getting really close to being a playable game. I mean, one of our objectives was to move this box around to be able to avoid slime and things like this. So this is pretty nice. I mean, it means we're getting very close. We only have a couple more things to do, and then I think our game will be in a really, it'll be playable. We can play this game. We can make a maze and play it. One thing I wanted to do really quick is basically give us the ability to reset the obstacle position. So notice, you may have noticed that when I was testing this scene, if I move the box and then I hit some slime, the box stays where it was. Typically, for most games that you play, there's a sense that when you die, everything kind of resets and you get a new chance, a fresh start. I do like the idea, though, that maybe perhaps as you design levels and things for your game, you could maybe play with that idea, and you could variably reset the position of the boxes. So maybe there's this sense that if you die, it's not like time is resetting. It's just that you're resetting, sort of. So it's up to you. I mean, I'm going to make it so that the box position resets, just so we can write some more code and mess with that and have the option to do it. And we already know how to do it. We're doing it for the player, so we're just going to do the same thing. So it's not super important. But yeah, we'll go ahead and do it really quick. So I already described all this. Basically, what I'm going to do is I'm going to copy this code, and on the movable obstacle, I'm just going to add this function, set position, just like we have on the castaway. Up here, it's called set position. I just used the same exact code. So we want the ability to do this. And we're going to do this from the level script when we initialize. So here we're initializing the castaway and doing a handful of different things when we initialize the level. I think for the movable obstacle, we don't necessarily need to add an initialize function because it's only doing this one thing. So I'm just going to call set position explicitly. So we'll go ahead and do that. Movable, so it shows up here already, movable obstacle. Say set position, and that comes up. Now, we don't have a way to track the position of the obstacle. We don't want to set it to its current position because that doesn't fix our problem. If I do just the position of the movable obstacle, well, when I move it and reset, it's just going to stay where it is because I'm just setting it to what it is. So we want to get the position that it's in when the game starts. The way we did that with the castaway is we created this other little node, this helper node that's called start position. And basically that just let us set a position on the game board that doesn't change in the level as you move the castaway around. And then we can always go back to that position. We can do the same thing for the obstacle, and we can do that for every obstacle. We can do that for every single obstacle that we create. It's a bit tedious. I mean, there's certainly ways to do that differently, but I think it's okay. The way I outlined doing that is basically you add a position 2D node like I just did. So, but the way I outline it, I do it as a child of planet 0 in the notes. And then you need to call it something new. So I called it movable obstacle position. What you could do though, is you could make it a child of the movable obstacle. So this position 2D, well, I guess that is a problem actually, because we made we made node children lock so that you couldn't move them separately. Well, okay, we'll just put it at the top level. It's okay, there's no harm in doing it like that. I'll call it movable obstacle pause. And basically, if you wanted to make more instances of this movable obstacle, and you wanted to track all of their positions, you would just have to make a new one of these each time, if that makes sense. There might be a better way to solve that problem, which I can think about. Maybe one of you has already thought of a way to solve that problem a little bit better than I have. So yeah, I'd actually be curious if someone has an opinion, just thinking the way the stuff is laid out. But yeah, I mean, one way to do it, for example, would actually just be to store the positions in the script. So what you could do, for example, which I don't think that's that bad. I've definitely done stuff like that before. So what you could do, for example, is you could set up your movable obstacle. And you could say, put it here. And then what you do is you'd note in the output here, or just by hovering and then looking at the transform and seeing the position here. So X is 198, Y is 248. And then what you could do is inside the planet 0 script, you'd basically just have some variables like, whoops. You could have some constants or whatever you want. You could say var movable obstacle 1, vector 2. You'd say new vector 2, and you'd say 198, 248. And that would be movable obstacle 1. What is the problem? Expected end of statement. Got built-in type instead. Is that what I need to do? Let me check this. No, that's fine. There. Expected end of statement there. Huh. Not exactly sure what I'm doing wrong there. This looks fine. Sometimes get an error and I really don't know what I'm looking at. Let's go ahead and make this assignment. Am I doing this correctly? Let's look at some different vectors. I think I was mixing up my programming languages. Yeah, whoops. Okay, yeah, you can ignore the new keyword. So basically, what I've done here is I've made a variable called movable obstacle 1. Probably should be something like position, because it's not the actual obstacle itself, it's just the position. And then what I can do is reference that inside of this initialize script. We can't reference the editor view this way. So I'm just storing it based on what I'm reading from the positioning. But that way I could delete this node. Then I don't have to make a node for every single corresponding movable obstacle. So let's say I instance another one. So it'll by default, it'll call that number 2. And I instance another one. Oh, whoops. Don't want it to be a child of the other obstacle. So now I have 3. Start moving them around in different places and things like this. Like that. So now what I can do is I can hover over movable obstacle 2. I can check its transform again. So this one's 199 and 176. I can go back to the planet script and I can say there obstacle position 2, and we'll just copy this. We'll just copy this. Oops. And pretty much do the same thing. And we can just copy these coordinates. 199 and 176. And let's go grab the coordinates of the other one. Obstacle 3 here has coordinates 254 and 248. So we'll go back to the script. 254, 248, like that. So now we have all these 3 different positions that are kind of stored. I mean, there's even a better way to do this. You could use a list, which is a data type, or an array, which is a data type in GD script that we can make use of. And we could just list them all out. We don't have to write these individually each time. But then basically what we need to do is in the level initialization code, we're gonna by hand individually set these positions. I mean, there's a more optimal way to handle all of them kind of collectively, but the goal is, to implement a system where we can store the coordinates and then recall them here programmatically. So let's play this and we'll see that when I move all these boxes around, so we'll move that one a little bit and move this one over here and move this one. If I hit the slime, they all reset. So that's the objective of that kind of code. You can move the boxes again and swish them around all over the place, and they just reset. So yeah, we have we're at the end of time, but we have a really playable kind of level here that's getting a lot more interesting. We used our time for the most part, but we basically finished what we wanted to do for today. The only thing that was remaining was to make an animation for the box. And when I say animation, that's a strong word. Really all I wanted to do, which we can do pretty quickly, I just wanted to add a separate look for the box, because this looks really similar to the unmovable box or obstacle. So what I'll do here is just edit the base scene. I'm going to click the animated sprite. We have a default animation and a slime animation. I'm going to add a new one called movable, like that. And I'm going to go into my art, and I'm going to pick a tile that I had planned to use for the box, the movable box, which I think is in here somewhere. Oh, maybe it's not. I never added a tile for the box. Well, that's a shame. Okay. I could use a slime tile, or I could use these stairs, which I'm going to use for something else, but that's okay. It doesn't really matter. We'll just use the stairs. They're kind of cool. So we'll save that. And then basically what we need to do is go over to the movable obstacle. And that's kind of cool. It actually just by default selected the new animation. That was pretty neat. I did not expect it to do that. Yeah, so that's what we want. We wanted to use movable. Great. Did that affect slime obstacle? No. Wow. Wow, it just worked. Pretty cool. I did not know it would do that. Oh, but it did affect the obstacle. Okay, we don't want that. So we'll go to animated sprite, select default there, save that. This should use movable, save that. The slime obstacle, thankfully, was not affected by all my goofy changes, so great. So now we'll click play, and you can see that all the movable obstacles look like stairs, which I'm not really a fan of, but it's fine. We'll get those changed by the next class. That's pretty much it. The last part is just something you can do on your own. So maybe try making a puzzle. I mean, now you have a lot of elements. You have slime, you have movable obstacles. You could make a little maze of obstacles and movable obstacles, and you could basically try to have the character escape that maze. And next week, we will try to reach an objective. So we'll add an objective to the maze that the player can reach, and then it basically gives us some indication that you've achieved the objective by displaying game information. Yeah, that's it. Thanks for joining. If you were able to join, maybe on Facebook or something like that, and hopefully see some people next week. I think that should probably be the end, if not almost the end next week of game stuff. And I definitely had a couple of ideas for the next group of sessions, which I'll need to remember what they were, but I think maybe some computer graphics or something like that. We talked about
It'd be a lot of fun. So yes, thank you again. Our next class will be next week. So that is I can have the calendar up the 7th at 6:30. Again, we're planning to do this last one virtual as well. And then we can adjust everything else if we wanted to do another session. If you do have a game that you've been working on, feel free to bring it. I think that would be a fun thing that we can all look at how each other's games happened, and help troubleshoot if there's something that's not working the way you want it to. But again, thank you everyone for joining us. As I said, Page's information is in the chat as well as in the comments, his email, the sign up for office hours, as well as the GitHub to work on this if you were doing it from home later. If there's no other questions, there's nothing on Zoom. I'm just going to double check Facebook. I don't see anything. So if there's nothing else, you can have a great day.
Great. Yeah. And actually, on that note, I think that's a really nice idea if people are working on these independent games. And also, even if you are maybe, not jumping into your own game yet. Yeah. Maybe if you want to design a level or something with the kind of components that we have, or just anything at all. Yeah, that would be really great to bring that in. So yeah, we can definitely take a look at those. That'd be really cool.
All right. And if anyone else has any questions, you can comment on the Facebook video. I check them fairly regularly, or you can just contact Paige directly.
Yes, absolutely.
All righty. Thank you, everybody. Have a great rest of your day. Paige, I'm just going to end the whole thing unless you need me.
Nope. All good. Thanks,
all right.
Jennifer.
Sounds good. Thank you. Bye.
All right. Bye.